For my studies, I'm not going to lie, I am very behind on both theory and coding. I would say I want to focus on coding more still though, just because I'm better at it than theory.
Ah,
It's more because my current class, the teacher is kind of not that good at it, and he kind of drones on and on about his current lifestyle instead of the actual classes, and like,
oh, okay. I got that. Okay. So, okay, now I got that. So actually, I think your your problem is almost the same like other students who came to me before. So most of them they would like to focus always on programming. But then, how was your results on the? Did you take an AS, the AS exam?
yes, I got a C in AS actually, which was why I wanted like tuition.
So you are not so strong in programming. That's what I'm trying to
No,
understand. Okay.
like
Mhm.
I'm okay at it rather than like theory, but I think I just like haven't really been okay with class, like our school classes in general. I've been like trying to just get by studying by myself, which like clearly isn't working. So
Okay, I understand. So, okay, no problem. Let me just give you a little bit introduction that will help you either in our computer studies or even your other studies. So this is
okay,
just typical neuroscience knowledge that actually help um, most of the students to be able to study well. So if you understand how your brain works, then you're able to adapt your study plans and study times according to what your brain was designed to. So okay, this is just a little introduction that I always give to all my students. So just bear with me. It's only a few minutes, but I believe you will benefit from that. So can
okay,
you see this is our brain, okay? And we have two types of brain or a memory, kind of memory. So we have something called working memory, and that is located, let me try a different color. So that is located somehow in the front part, our forehead, okay? And we
okay,
have a permanent memory. So the permanent memory is actually spread all over this portion of our uh, brain here, like that. And it is just a thin layer, okay? So
okay,
our working memory is actually quite limited. So of course, what I'm trying to tell you, this applies to the average student. Some have more abilities, some have less abilities. Our working memory can only handle four information at the same time. This is our working memory. Can only handle four types of information at the same time. So if you try to put a lot of information there, something will turn out missing. So you will forget it. Okay. So we would like always to store the information in the working memory into our permanent memory so that we don't forget it. So when you are studying, typically, or even listening to a class, your working memory, the information is passed to your working memory. And there is no straightforward relation um, or a path between the working memory and your permanent memory. So this is a permanent memory, okay?
yeah,
And to be able to pass the information or take the information from the working memory, there is two things that help in that. This is the white pieces on the screen. We call that a hippocampus. So okay, I don't want to explain too much about the brain, but you will understand now why I'm giving this little introduction. Um, so this hippocampus actually act as an orchestrator. So it orchestrates moving the information from the working memory here until it reach the permanent memory. But the permanent memory is slow in receiving information. So what happens that sometimes the information is moved from the working memory to the white part, which we call it hippocampus, very fast, but
Yeah.
the information flow from the hippocampus to the permanent memory a bit slower. So it means that actually in the class,
Excuse me.
no problem, in the class, and or if you are studying alone, the hippocampus actually gets saturated every 10 to 15 minutes in adults. So it's like you are pouring information in a cup, and or pouring water in a cup, and then after a while, after 10 minutes, this cup got filled out. So when it filled, means that the water will flow out like that. So it flow out. If it flow out, this means that you need to stop pouring more water in and relax for 1 or 2 minutes. So when you do that, you allow your hippocampus to pass the information out to the working memory. So typically, teachers who understand this concept, every 10 to 15 minutes, they will busy themselves with something, either checking their book or cleaning the board or doing something or just sitting, or they just want take 1 or 2 minutes in silence to allow the brain of the students to be ready to take more information. So if you are sitting alone studying, every 10 to 15 minutes, you will somehow feel saturated. Or even if you don't feel it, just take 1 or 2 minutes of silence. Don't do anything. Don't think about anything. Let your brain take 1 or 2 minutes of rest and then continue studying again. Did you catch anything from what I said?
Yeah.
Okay. Can you tell me what did you manage to catch? Did did I make it
Um.
simple enough or it was not simple?
Yes, it's actually. I think I grasped it. It's like something like our working memory can only work for like 10 to 15 minutes, and so the teachers like find time to like in between the people who know this theory, take kind of a break, like wipe the whiteboards and such, right?
Okay, great. You're great. So actually, one of the techniques that we need always to practice during the class is that I ask you questions. That questions is not intended to prove you are perfect or not perfect. Not at all. So the questions and recalling information that you take out from me or from any class is supposed to strengthen your memory links inside. And that helps the information to last longer. So so don't think that because I'm asking you questions, I want to prove you are good or bad. No, there's no intention in that. The the time to prove you already studied well or not well is not now. It is after 2 or 3 months in your exam. But here, when I'm asking questions, I'm trying to give your brain a chance to recall the information, and that strengthens the information inside your permanent memory. Okay, recalling information is quite strong, and you always have to practice that. So you don't, if you want to study, do not just keep repeating reading information before the exam. That's the best thing that you can do to strengthen the position of the information inside your permanent memory, to do a recall. Write out information from your brain, write it out, or just speak it out. uh, Only by thinking of it, not by reading a book. Okay, is that understood?
Yeah, yeah.
Perfect. Okay, so again, this is how the information is actually stored in our brain. It's all connected together. Information, although sometimes seem unrelated. So now I'm going to teach you computer science, but I'm telling you there is other subjects that you study every day that actually connect together in your brain. The information is actually is like a net inside your brain. But actually, this net is not built once you study information. So it takes time inside your brain to come up with the links like that. Okay. And this only happens when you are sleeping. That's why sleeping is extremely important for your brain to build links between the information that you study. So I would say watching videos does not help your brain at all. It actually consumes your brain abilities. So, but if you read a normal book just as an external knowledge that even have no relation to your studies, actually it's good. But of course, as I said, videos is not good. So even you see that, okay, reading a book about history or about mathematics does not really help you in physics or science directly, but actually in your brain, the neuroscience say something different. So all the knowledge inside your brain actually connect together and help improve your understanding and thinking. Does this make sense to you?
Yeah, yeah.
Okay. So, okay. Now let me move to the last thing that I would like to talk about in memory. So your brain works in two modes of thinking. Something called focus mode, which you are in now when you are listening to me or even studying. This is a focus mode, and this is the diffuse thinking mode. So this diffuse thinking mode is actually interesting if you are able to trigger it to work. So if you are trying to solve a math problem or even a programming problem, and then things are stuck out with you, so what do, you don't keep trying to figure out the problem. So I would say um, take a rest, 1 or 2 hours, go do something else. Um, if you are maybe just close your eyes, give your mind maybe 30 minutes to rest. This kind of rest put your brain in a diffuse thinking mode. That's why sometimes people, when they are taking shower, they are more relaxed. Ideas come to the brain. So you're not thinking about anything, but the ideas keep rushing into your brain. Ideas to solve either problems or good ideas to handle things. This typically happen for people who keep practicing using the diffuse mode thinking. And does this make any sense to you?
A little, I guess. I
Okay.
mean, I get for me. It sounds more like getting a clear mind before going to
Yes.
practicing.
Somehow, yes. Somehow, yes.
Uh, okay.
Okay. So, okay. Do you know how you can put your brain in the diffuse thinking mode?
Not really.
Okay. So by relaxing, by sitting in front. So uh, if you go walking in a forest, not thinking about anything other than walking, so you are putting your brain in a diffuse thinking mode. If you go take a shower, not thinking about anything, your brain goes to the diffuse thinking mode. And they have, so if you close your eyes and maybe do some actions with your hand, but not thinking about anything, your brain moves to the diffuse thinking mode. Did I manage
Uh,
to get it clear this time?
yes, yes. Okay.
Okay, so now let me move a bit here. Uh, okay, before I move to talking about pseudocode or even about you're taking Python, right? Or
No, our courses are set for VB.net actually.
okay, are you in Taylor? Taylor? Are you studying in
Yeah,
Taylor? Oh, that's why. Okay,
yeah, I'm a Taylor student.
yeah, okay. So okay, slightly okay. So I'm not able to teach you VB.net at this current class because I was thinking that I prepare my slides based on the Python. But in the next classes, then we are able to talk about that because I already taught other students last year also about VB.net. So, but let me
Uh,
put some concepts here for you, and that is important for us to be able to talk about programming in general. So, okay, do you know what is appearing here on the memory, on the screen? Sorry.
like a random access memory, right?
Yes, exactly. So this is the old form for old computers 30 or 40 years ago of the RAM. And that is the RAM that is put inside a laptop. It's slightly smaller inside. This is a RAM that fits, or memory that fits inside a computer. Okay. So I move to the most important part here that is important for us when we're talking about programming. Okay. So here the memory actually, or the RAM, is divided into two parts. So do you know every house in Malaysia got a number, right? So there is a street
Yeah.
and there is a number for the house, right? So
Yes.
you're able to put an address, a postal address, or when you're shopping something from Shopee or Lazada, you order something, then you put your street address and your house number, and they are able to reach you out, right?
Yes.
Okay, good. So in the memory, it is divided inside into two places. One place is for addresses. So I would consider, so we can mark the address in the memory is 1, 2, 3, 4, 5, and so on. Okay. And there is another part that this part is we store the information inside it. So there is part that that show us this is the address of the memory, and the other
Mm-hmm.
part actually we are able to store information inside. Do you know what's the meaning of variable? Do you know what it means when I say a variable?
Yes, but I
What
don't
is a
think there's
variable?
like an actual. I don't. Is there a definition for it? I
Okay, so
we know it as like declaring a variable and then assigning something to the variable.
perfect, perfect. So good. So actually, when you are assigning the variable, what happens under the hood in the computer is that uh, when so either it's a Python or VB.NET. So the computer internally, when you tell him, okay, I need a variable with the name, for example, it's called, let's say, number, NUM, and you put 10 inside that variable. So it will go to the memory and reserve a place, and it will call it num or number, like NUM, depends on the variable name that you decide, and it will put 10 inside the place here. Okay, so did you study anything about assembly language? Do you know what's the meaning assembly language?
I don't think so.
Okay, good. So when we study about assembly language, you will know that previously, before we use high-level language like VB.NET or even Python, then we turned out the programmers used to write assembly. So this assembly is quite difficult language actually. And when you write assembly, which is a low-level language, you talk to the hardware directly, and you do not write variables with name like that. You have to tell the computer to actually go to which address in the memory and put what information in that address. So it's quite tough. Let me share with you how it looks like to actually deal with assembly language. So have a look here, please. So, okay, let me try to clean that here. So So Python and VB.NET. So, okay, first, Alisa, I am talking slowly at the moment. I'm able to talk a bit faster, but
Ah,
until I'm able to detect your speed of grabbing what I'm saying, I will start from slow and increase a little bit until you're able to catch up. Okay? So,
okay.
so
Actually, would it be okay if you start by speeding up actually? Because I have ADHD and I actually work better when I'm struggling to catch up. I'm better at focusing when I'm like struggling to catch up rather than like having things at my pace.
Oh, okay, okay, good. So yes, okay, good.
All
So
right.
okay, if we are if we are trying to add two numbers and put the result in a variable like that, so sum is a variable, okay, and we are trying to add 5 plus 2. This is a high level language. But if we would like to look at the assembly language equivalent of that one line of code, so we will see that we have 3 actually instructions need to be done. But this instruction does not have 5 and 2. They only have 8, 9, and 10. What is that? It's so much different from 5 and 2, right? So actually, the RAM here is look like that. And there is address called 8, and we have address called 9, and we have address called 10. And what we are doing here, so the first instruction that is given to us here is called LDA. So LDA 8, it is telling go to the memory address 8 in the RAM and grab whatever information here, go put it in a CPU. Do you know what the mean CPU or a processor?
Yes.
Okay, do you know that there is a registers inside the processor?
I think so, but I don't really remember what a register is.
Okay, so a register is like a place, a limited spaces inside the CPU to store information. So it's slightly like a RAM, but not so big as a RAM. It's quite limited in space. So it can store 1 or 2 information at maximum. So there is certain registers inside the CPU that we can utilize directly if you are using assembly language. If you're talking about a high-level language like Python, VB.NET, we will not be able to do that. So again, LDA, he's telling, go to the memory address 8, grab whatever information inside that address, which is 5 in this example. So we will put 5 here in one of the registers inside the CPU. Okay. And again, if I speak faster than you can catch, then you slow me down. So, and then this is the first instruction. The second instruction saying add 9. So he is telling, go to the address 9, grab whatever information in that memory address and add it to what you have grabbed and put in the register in the previous instruction, which is 5. So here he will grab 2, he will add it to 7, and then he will wait. So now we have not 5 anymore, we have 7 stored inside the CPU registers. And then we come to the third instruction, which is called STA10. So he is telling, go to the addition or the place in the CPU that you already make the addition and store 7 and grab 7 and put it inside the memory address 10. Did you catch anything from what I said?
Yes, actually, that worked great.
Really? Okay, good. So,
Yeah.
So let me think with you, which is more easier for us to grab or to write assembly language that have just to make an addition, you need to go and see what memory address you're going to use. You have to remember in your brain which memory address you used before, and you should not overwrite information that you write in the memory before, because again, if you this is just to do addition. What if you want to do here subtraction and multiplication? So you always have to remember what memory address you use, and you should not ever overwrite the information that you stored before in. Did you catch that?
Yeah.
Really? Sure.
Sure.
Okay, good. So, okay, the best thing in an assembly language is that it is translated directly to a machine code without so every line of assembly language like LDA8 translate to a machine code like that. So what is actually machine code? Did you hear about that before?
Yes, it's like the one that like directly I wouldn't say talk to, but like directly talk to the computer using that, right?
Yes. Okay. So do
But
you know
not necessarily.
why computers only understand ones and zeros? Do you know that?
No.
Okay, so the computer inside is actually is electronic circuit inside, and inside is actually inside the processor itself. It is a set of transistors. And did you see a transistor how it looks like before?
Yeah.
Okay, so a transistor only can carry two things. It can only be either on or off. So if it is on, it will carry one. If it is off, it will carry zero. So that's why, because the computer inside is only feel full of millions of transistors, so it only can store information as ones and zeros. So everything stored inside your RAM is ones and zeros. Everything inside your hard disk, either it's a music, a videos, or even how to say word files, all or document files is all stored in ones and zeros. So did you know before there is something called ASCII table?
Yes.
So you know that for every number or for every letter, there is an equivalent, um, um, something equivalent, a number equivalent. So if I say A, there is an equivalent number to that A. And this number can be translated to binary code ones and zero. Did you do this conversion before? You can
Uh,
you convert from, for example, 10 to a binary number of ones and zeros? Did you do that before?
oh, yes, yes.
Okay, so what? Okay, for you to understand, if I keep appearing or making the ones and zero come into your screen, you will never understand anything. So the information is switched on and off between the screen that is appearing to your eyes. So when it appears to your eyes, you see, okay, low level versus high level language. But actually, this information, when it is stored inside the computer, is only stored as ones and zeros. But when it showed to you on the screen, it showed to you using a conversion from the ASCII table. So it converts whatever ones and zeros that is stored to the equivalent ABC alphabets or even numbers. Okay, and then when it go to store it again in the hard disk, then it switch it back to ones and zeros because this is the only format that the computer can store inside itself. Did I manage to get this clear, or it's not so clear?
It's clear. It's clear.
Perfect. Um, okay, let me see here. Good. So, okay. Do you know what the meaning uh, a translator is? Do you know what it means, a translator, or even a compiler, or even interpreter? Do you know what is that?
Um, I roughly know it, but I'm not gonna lie, I forgot the like definitions for it
Okay,
in the
so
exams.
no problem. Okay, so you have to know that any language that we write, any high level language that we write, even a low language also need a translator. A translator can be a compiler or interpreter. So what is the difference between a compiler and an interpreter? Actually, compiler and interpreter do almost the same job, but certain languages like C++, for example, use compilers. Python, Java, they use interpreters. And also VB.NET, they use compilers. So compiler is actually what? It takes the high level language that you write, the lines of code that you write, and it translates it to ones and zeros that the computer can understand. Because again, what you write here, the computer is just a dumb machine. It doesn't understand anything. So you have to really speak the language that the machine understand, which is ones and zeros. So everything you write on the screen, the computer have no idea what it means. You write T, he doesn't differentiate between the I and the T and the H. He doesn't understand anything. He only understands it when you translate it to ones and zeros. So when you write any code in VB.NET, it needs a compiler. After a compiler, then it goes to ones and zeros, and only then the computer can really understand what is that. Did you catch anything from what I said?
Yes.
Okay, good, good. Did you didn't hear any information like that before?
No, actually, I caught what you said.
Okay,
Uh,
Okay, good. So let me also try to understand so that we can speed up things also on the next. So if I know where you are, then I'm able to push things to you. Do you know what is meaning algorithms?
Mm, I know what an algorithm is, but I think the problem with a lot of my like current studies is I remember the vague idea of things, but I don't remember the like textbook definitions of it, which comes out a lot in my theories.
Okay, so I am not interested in just giving to me information just that you read in the book. I just want your understanding, and but also you have we have to bear with ourselves together when we are working in a class. That I will always try to ask you questions. Believe me, that will help you
Ah,
and to in the recalling process. This will help you in the exam. Okay, so
okay.
algorithm is a set of steps that you do to solve a problem. So if I ask you to make a cake, you actually need the steps to make a cake, right? If you have a
Yes.
pancake, there is, okay, you need to bring this amount of flour, you need to mix it with the milk a little bit and shake it a little bit, and then maybe add a little bit sugar, and then take all the mix until it is maybe solidifying the shape or everything is dissolved, and then you pour it out in a maybe some kind of cooking wares that you want to put in the oven, and then you put it in the oven, and then you wait for maybe 10 minutes, and then you check it's burned or not, it's cooked or not. Then based on that, you decide to take it out and then start to eat. So the steps that I said just now is kind of algorithm. So this is the algorithm that you take to make a cake. So okay, you mix this amount of flour, this amount of milk with the sugar, you shake it. Oh, this is the steps. So algorithm can work for anything in life. It can, when you buy something from IKEA, what happens? It comes with an instruction manual. It tells you step by step how you can construct a table, construct a chair, or even a bed. Did you see that before?
Yes.
Okay, so these steps is kind of algorithm. Did you get the feeling or the meaning? What is it, algorithm? So
Yeah.
okay, so I don't need the exact what the book really say. I want the understanding. The most important is understanding what you really understand.
Oh,
Okay, so
okay.
okay, good. We are able to express the algorithm in actually three things. Flow charts. I think you have seen flow charts before.
Yep.
Okay, and pseudocode. Have you seen pseudocode before?
Also, yes. It's in
Okay,
AS, right?
yes, definitely. So and Python, of course, you didn't see Python, but you have seen VB.NET. No, you didn't see VB.NET before, or you see it in your class, your current class?
Um, I've seen a few. It's not
Okay.
like, yeah.
But okay, now let me understand. Did you solve any problems in VB.NET?
No, we've learned until like, assigning variables and such, and that's
Okay,
really it.
so we need to start from that level. Okay, that's good. So um, okay, that's good. What I would like to say, we only have 5 minutes remaining on this trial class. So I think just let me share with you something here. Do you know why we need to learn actually pseudocode just before we start looking into the pseudocode?
It's like a more generic style of like coding that like is present in like every coding language, right?
Okay,
Like it's kind of how it works.
yeah, somehow you have told what you told me is somehow correct, but actually pseudocode is an English style representation of what is an algorithm to solve a problem. So if we are having a problem that we need to add some kind of numbers in a certain way, so we write the steps to do that. And if we want to write the steps, regardless of we are using Python or VB.NET, we use a pseudocode because it's like simple without any language specific internal syntax. So I'm able to write in a pure English how I'm able to write the steps to solve a problem. So that's why they use a pseudocode. And they use this programmers who are using different language, they use to express their ideas to solve a problem in pseudocode because it's understood by everybody. It's just a common it's a more to English language kind of syntax more than it is to language specific like VB.NET or even Python. Did I manage to get that in your brain correctly?
Yeah.
Okay, so do you know if I want to tell you, do you know what is the meaning constants in pseudocode?
A constant.
Mm-hmm.
Mm, kind of. Not really.
Okay, so a constant, okay, so you don't know the difference between a variable and a constant, right? And this is what I guess, right?
Yeah.
Okay, so
Yeah.
a variable is something that you can assign a value to it. So we can say num can take 10, and then later we can say num equal 1. But if I say this is a constant like that, and I put it sometimes they accept that you put a constant like that, or even just put the variable as capital letters. So if you say let me see num like that, so definitely I'm talking about a constant. And then when I put 10 here, I cannot change it at all during the code, during running the program. So it should take a value and initialize to a certain value and should not change at all. So you have a look, please, with me here. So this is how we define variables, right?
Mm-hmm.
Declare score as integer. So we are declaring score as a variable and of type integer. So do you know if I say declare score as an integer like that, so declaration does not put any value inside score. It's just telling reserve, telling the computer, please reserve this amount of space that can take an integer and mark it as a score like that. So we put inside the RAM, oh, please reserve a place that's called a score and prepare it for storing information when I'm ready to do that. When I'm ready is here. So here I'm telling, oh, go to that place that you reserved inside the memory to take an integer and put 20 inside. Did I manage to get to you correctly?
Yeah.
Okay, good. And then let me see. So you see here, okay, have a look here, please. So when I say, okay, yep, okay. So as you see here, this is a constant, and I set threshold 60. So when I say a constant threshold A like this, I'm telling it this is a constant that cannot be changed at all during our code. So you cannot come later and tell me, oh, I'm going to change the threshold to from 60 to become 100. Did I manage to get it correctly to you?
Yes.
Okay, so I think this is the final thing that I'm going to say now in our class. We have less than 1 minute remaining. So tell me, um, uh, see here. Every class, typically we have a recording for the sessions, and
Mm-hmm.
I'm going to give you an address like that, where you can go and fetch out the recorded lessons. I typically upload that after 36 hours. Um, I think the Zoom will cut in any second now, and you will have the slides and the codes that we write inside the class for every class, and you have them in the same URL every time. So I think for now,